Well,
Awesome.
good evening to you all, and thank you for being here. This promises to be like a very interesting talk. We have Dr. Becky Alexis-Martin from Manchester Metropolitan University, who's going to talk to us about global research in the area of, well, from bananas to bombs, we believe. She may mention her book, so sit back and enjoy. Over to you then, Becky.
Thank you so much. That was such a lovely introduction.
Oh.
So yeah. So I'm Dr. Becky Alexis-Martin. I'm here tonight to tantalise you with radioactivity, and I'm going to be telling you all about our atomic Anthropocene. And so what do I mean by that to start off with? Well, it's this idea that the age of humanity, the age where we really began to have an impact upon Earth, was emergent from that moment where we produced nuclear weapons. And when we kind of dispersed tiny amounts of radioactivity, but radioactivity out into the air to land into the sediments and to stay in our environment. So it's this idea that our radioactive activity, that's quite hard to say, has had this really profound effect. It's had positive impacts. It's given us opportunities for nuclear medicine. It's provided nuclear energy, but it's also had this really tragic consequences through nuclear warfare. And so my specialism, I am a human geographer, believe it or not, but I'm still a scientist. So I started out in natural sciences, wiggled over to the environmental sciences. So I did a master's in environmental management. And then I did my PhD in computational human geography. So I made a new model for understanding radiation protection. And then after that, I was like, well, there's a whole world out there, literally. I was, I sat and I thought, well, there's more to life than models and simulations. I don't want to sit in a basement and program anymore. I need to get out. And so this is how my work on the atomic Anthropocene came about. I bought myself a ticket to Hiroshima, and before I knew it, I was exploring the peace gardens. I was talking to Hibakusha. I was learning about the impacts of nuclear weapons on the detonation of in Hiroshima upon the community, and it's all kind of gone from there, really. And so it's resulted in me writing this book called Disarming Doomsday, which has now, weirdly for me, become prize-winning. So it won the L.H.M. Ling Outstanding First Book Award. I never thought I'd write a book. If any of you are dyslexic out there, I have a PhD. I've been a journalist for The Guardian and The Independent, still write, and I've written a book, and I'm dyslexic. Just as a little kind of aside there, because I know some people don't realise what you can do with dyslexia, so I think it's worth mentioning as well that I am a dyslexic academic. And today I'm going to be talking to you about my exploits and my exploration of nuclear culture from, as my title says, bananas to bombs. So when we think about nuclear places, you can't think about place by itself. I told you the geographer was going to come out, right? So I told you I'm very geographical. And I like to think about nuclear culture through place. And so places, they consist of different landscapes, zones, bodies and communities that are bound together. They're entangled with past, present and future nuclear technology. So how do science and culture connect? Well, I think this is really interesting because obviously the science was there long before we were. And when we think about things like nuclear reactors, we think of things maybe like Sellafield, these places that generate energy. And we think of them as being a kind of contemporary phenomenon. We think, the last 75 years or so was kind of the advent of nuclear energy, right? And it's this ongoing industry. But actually, the first nuclear reactor arose 1.7 billion years ago. So this is a true, amazing scientific, radioactive fact, I think, well, nuclear fact. And there was this study, some geologists found that there was natural fission, so the process that creates nuclear energy, natural fission arising deep within the geology of a basin in Gabon. So within this zone, you had these natural nuclear reactor zones in the uranium ore, surrounded by sandstone and granite. So it's this natural geological phenomenon. So I don't know about you, but when I learned about this, I was just like, that is amazing. You know, we think we get there first, right? We think, oh, we are the pioneers of the nuclear age, humanity. Well, that's what I started with. But actually, when we look deeper into the geological record, suddenly we realize that it's not just our innovative ideas alone. So I think that's quite cool. But I'm going to give you kind of a bit of a potted history of the radioactive. So it was way back when, in 1895, when Wilhelm Röntgen discovered X-rays, right? And then Henry Becquerel discovered that uranium salts give off kind of natural, you know, similar rays naturally. And then Pierre Curie, Marie Curie and Henry Becquerel received the Nobel Prize for Physics for their work. Which is quite amazing, really, I think. I always think Marie Curie was an absolutely inspirational woman. She invented the X-ray machine, you know. So that meant that it could go out on the battlefields and kind of support injuries with the armed forces. I think that's a little thing that not everybody knows about Marie Curie. It's kind of cool. And so time goes on. 1945, we have the Manhattan Project. You know, we're in the midst of the Second World War, right? Nobody really knows what to do. But there's a huge amount of conflict. And the US, they're in this race to try and develop what they call the atom bomb. And they've got this secret facility where they're designing it and developing, and they've got all these amazing, you know, the best scientists in the world to help produce this bomb. However, there's a pushback. Not everybody wants this bomb to be produced. And a month before, 50 of the scientists from the Manhattan Project deliver their letter to President Truman. And this letter inside, it describes how they don't want this bomb to be used against humanity. But regardless, a month later, so on the 6th of August, Hiroshima is the first bomb ever used. Hiroshima is the first bomb. Oh God, I'm going to stop. Hiroshima is the first place bombed. You know, the first place where nuclear weapons are used in violence against a place, right? And it was bombed with a bomb called Fat Man, and then Nagasaki was bombed with a bomb called Little Boy, that was just 3 days later. And of course, that was the end of the Second World War. But it's still questioned as to whether that second bomb was really needed. And it's something that I guess only history will know, you know, and only people at the time will know. But then the nuclear takes a turn for the industrial. So in 1956, in the UK, we have the first commercial nuclear reactor, Calder Hall. It's opened by Queen Elizabeth herself, so she goes down there. And it's seen as this kind of new opportunity for energy, you know, energy production. But also, it's the same time as the Cold War. So you've also got these other things going on at the same time. I'm sure it's no coincidence that by 1957, 1958, well, in 1956, the UK was testing nuclear weapons in Maralinga, Australia. And it was also testing nuclear weapons in Hiroshima. And I've had the pleasure to work with the British nuclear test veteran community to learn more about their lives as part of my research. And it's been a particularly special bit of my work. I've worked with them now for years, like 4 or 5 years now. And I've done a report and a few papers about them academically, and they're in my book, of course. Then as we think onwards, you know, we're still in the depths of the Cold War, but then we start to see things like nuclear accidents emerge. So the 3 Mile Island accident in 1979 on the 28th of March, that happened in the US, and that kind of raised everybody's hackles. People started getting a little bit worried about nuclear energy. And unfortunately, that was followed in 1986, on the 26th of April, with the Chernobyl nuclear accident, where reactor 4 experienced a meltdown. Interestingly, though, there were other reactors, and I am going to tell you the story of what became of the other reactors a little bit later on. So I talked a bit about nuclear weapons. I've talked about them being used in warfare. I've talked a little bit about these countries who tested them. So they were tested by France, by the US, by the UK, by China, by the former Soviet Union, so Russia. And those were kind of the 5 original nuclear weapon possessor states. But there were others as well. You know, when there is power, it proliferates if possible. So Pakistan and India, Israel, and now North Korea also have nuclear weapons themselves. However, there has been progress to prevent further proliferation, and during the Cold War there was concern that we would all destroy each other, you know, mutually assured destruction. So in 1996, the Comprehensive Test Ban Treaty outlawed weapon testing internationally, so it made our world a safer place. You know, it meant that you know, people were not supposed to test weapons. Although, of course, how do you solve a problem like Korea? We know that North Korea is still proliferating, and you know, during the 2010s, there were several occasions when North Korea undertook nuclear weapon tests to try and demonstrate its might and its power, and to claim that place on the world kind of, I don't know, nuclear arena. So that brings us up to March the 11th, the Fukushima nuclear accident, which was obviously this very impactful accident. It was number 7 on the INES scale, which is an international nuclear emergency scale. And the reason I mention that is because the scale goes from like 1 to 8, so it's you know, really high on that scale. And then things are changing though. So on the 7th of July 2017, the UN Comprehensive Nuclear Weapon Ban Treaty was first kind of created, and it's in the process of ratification now. So there's 5 more ratifications needed before it comes into force. And we still don't know what the implications of that are going to be for nuclear weapon possessor states if we've got a treaty that outlaws nuclear weapons. So it's going to have big implications for the UK potentially. Perhaps we'll just ignore it. Who knows? So that gives you this kind of insight into kind of the first science, culture, technology, the way that these things kind of link in from a nuclear perspective. You know, from the pioneering scientists to nuclear catastrophe.
Becky, I've got a question. I've got a question here from Sally in the chat, and not being a nuclear physicist, I would appreciate if you don't know the answer. The question is as follows: some people say that reactors were uranium based so that they could make bombs, and that thorium was rejected because you couldn't make bombs from it. But would thorium be better?
Both thorium and uranium reactors work, and at the time that nuclear energy was kind of nascent, that it was coming into the fore, then yeah, one of the purposes was not just to produce energy, but also to produce the fissile materials needed to make nuclear weapons. So yeah, thorium could potentially be better. No, that's a really good question, actually. And thank you, Sally. And do feel like you can interject and ask. I always say this to my students: there's no such thing as a you know, as a silly question. They're all really good questions. So yeah. So I imagine that in future we'll probably have thorium fast breeder reactors. But that's just my perspective. So thank you. Right. So thinking about ionizing radiation, for those of you who perhaps haven't done physics at school for many, many moons, which is understandable, and you've got different kinds. So you've got alpha and beta particles, and then you've got gamma radiation, right? And I think the best way to think about it is, so your alpha particles are kind of perhaps larger particles. They can be stopped by paper. Your beta particles can travel for a human, so that's where you've got the image you've got there, and it's stopped by something like aluminium. Whereas your gamma waves, and they're non-stop. They are, you know, they can go, and they need lead to stop them, but their distance that they can travel is less far. So I'd think of alpha and beta as like your radionuclides, if you're going to use a technical term, and then you've got gamma rays or gamma waves. Do the gamma wave, but yeah, and that kind of encompasses the different types, at a very basic level, of ionizing radiation that you've got. So you've got alpha and beta particles, radionuclides, gamma waves. And within that, I think it's interesting to kind of think through. Oh, my slides should be sliding. It's not sliding. Give me a minute. And think about where you find radiation as well, because I think it's really interesting, actually. So we all have a little bit of radiation in us. Every single one of you is a tiny little bit radioactive. And some of that radiation will be natural, some of that will be artificial. And I think it's really good to kind of begin by thinking about where that radiation comes from. So you can have your radon gas from the ground, you can have buildings from the ground, food and drink, cosmic rays. So we've been bombarded by radiation as we sit here. Our atmosphere shields us a little bit, but there's still some radiation reaching us, so ionizing radiation. And then you've got artificial sources as well. So you've got things like nuclear power, nuclear weapon tests, mysterious other sources. I don't know what they are either. And then medical radiation. And I think this is an interesting image because it kind of shows you the proportion as well of where this kind of radiation comes from that we encounter in our day-to-day lives. And I think it's really important to clarify here that a little bit of ionizing radiation is perfectly normal. You know, we live and breathe and we eat and we survive. And the challenges with radiation is that if you are exposed at a higher level, you can have stochastic effects. So that means it's an increased likelihood that you're going to have health effects. And if you're exposed at a very high level, you get what we call deterministic effects. So that's things like radiation sickness, where you have this immediate consequence, you know, within the first 24 to 48 hours after exposure. So if you think of things like HBS Chernobyl and think about the liquidators who went in after the accident went, they'd be getting, you know, deterministic effects. They'd be getting acute radiation syndrome, right? And then if you think about, I don't know, perhaps somebody who was lived in a house with lots of radon gas in throughout their life, and then maybe they became unwell when they were older. And then that would be a good example of a stochastic effect. So it's cumulative, it's based on kind of your dose, how much radiation you're exposed to. And this is one of the reasons why for our nuclear test veterans, for instance, who've been exposed to a little more radiation than your average population, but there are challenges and that there's been kind of health difficulties among the community. So when we think about radiation, how do we understand it? So I'm going to start, I'm sorry if this is basic for some of you, but maybe some of you know a bit about ionizing radiation, maybe some of you don't. But I'd say a nice place to start is that we are all made from atoms, right? And you know, some of these atoms are unstable and they decay. And so that emits ionizing radiation, that emits radiation which carries energy and is capable of breaking down or ionizing the molecules that it encounters. And then the amount of radiation given off or emitted by a radioactive material can be measured using a thing called becquerel as a unit. So it's like an SI unit. So we use it in science to kind of measure. And so if I said to you right now that you've got about maybe 5,000 to 7,000 becquerels of ionizing radiation wibbling away in you, you might be like, no, I'm radioactive. And the truth is, yeah, you are. But actually, the scale is, you know, it's a tiny little bit of radiation when we think about it in proportion to, you know, how much radiation exposures you get from other things. So it's not something to worry about. It's something that I'm a little bit proud about, actually. I quite like to think, you know, when I'm doing my work, that I'm a little bit, tiny little bit radioactive. And so when we think about the emission and how it's emitted, that is called the becquerel. And then when we think about the amount of radiation absorbed by a human, so we could call that the grays. Grays is a quite common measurement used. So that's kind of how much you can like absorb, basically. And then when we think about the biological risk of exposure though, so we think about the consequences, we use a sievert for that measurement. So your sievert gives you an idea of risk. And I think that's really important to distinguish and determine between the different kind of options, the different scenarios. And so that brings me to bananas. So potassium. Did you know that potassium exists in 0.012% in this radioactive form called potassium-40? How cool is that? So it decays really, really slowly. It's not very radioactive. It's got a half-life of 1.3 billion years. That's huge, isn't it, right? That's like, you know, a sixth of the length of the time the planet has even existed before you get that level of decay. It's quite outrageously long. but bananas are rich in potassium. Oh no! And so what we do as scientists, some genius came up with the idea of the banana equivalent dose to help contextualize risk for day-to-day radioactive events. So, for context, going back to our CVITs, thinking about risk. So you remember CVITs, you remember risk, remember exposure and how much we can kind of take for our body. So if you received 5,000 millisieverts, that would kill half of those receiving it within a month. So that would be those deterministic effects. So the annual exposure limit for UK nuclear industry employees is 20 millisieverts. And 1 year of net exposure to natural radiation is 2.7 millisieverts. So you can see it's gradually getting smaller and smaller. The exposure to cosmic rays during a transatlantic flight is 0.08 millisieverts. And then one banana, 1/10 of a millionth of a sievert, or 0.1 microsieverts. So it would take 20 million bananas to induce severe or sometimes fatal radiation poisoning. So in the average British about 80-year lifetime, that's about 700 bananas a day. That's quite wild, isn't it? Any of you a fan of bananas out there?
Yeah, but I think I'd have other problems if I ate that many bananas a day that would kill me before any sort of radiation dose.
Exactly, precisely. So even if you tried the toxicity and the difficulty, your digestive system probably wouldn't deal with it very well. And to do that continually every day, yeah, you die from banana toxicity long before you die from a radioactive exposure. And if you want to know more about the data I've used, you can get it from the IAEA and the PHE. The IAEA, to demystify it, is the International Atomic Energy Agency. The PHE was Public Health England. I'm not sure what's happening with it at the moment, so go have a look. But I'm sorry if it's not there and it's been Borised. So there's loads of different ways of monitoring and detecting for ionizing radiation, both in fiction and both in, and fact, from Pip-Boys to radiation monitors used in Fukushima. And we're reliant on these to be kind of calibrated correctly to give us insights into kind of whether we're at risk or not. And I think that's really important, actually, because I know for a lot of the time, like we're reliant, we can't sense ionizing radiation ourselves. We can't taste it, we can't smell it, we can't touch it. It's entirely invisible. So we are reliant on these kind of instruments, these equipments, real and, if we're thinking through computer games, imaginary too, and to monitor and to detect what we cannot see, taste or feel. I think that's really interesting, like as a phenomenon and from a experiential perspective as well. It's probably why I study it, actually, is because I find that idea of invisibility so thought-provoking. So let's begin our world tour of the radioactive, and I want to take you first to Ramsar. So Ramsar is the most naturally radioactive place on Earth, and it's in Iran. And it's got these radioactive hot springs in particular. So it's got some of the highest level and natural background radiation levels on Earth. So annually, residents receive 10 times more ionizing radiation than the average person's maximum recommended occupational exposure. Yet people have lived here for millennia. So perhaps people have built up a little bit of a tolerance, perhaps as a community kind of resilience to that exposure. Or perhaps maybe, we just don't have the data. Maybe people don't live as long. Maybe they're affected by the, stochastic effects, like these long-term consequences of exposure. And we don't know. It's a bit understudied. So maybe somebody could go and find out for me, and then I could talk about it and go, I found out. So another place I want to talk about a little bit as well that I think is really interesting, since we're doing our whistle-stop tour of the world, is Los Alamos. So Los Alamos is in New Mexico, which is in the USA. And arguably, it is the home of the atomic bomb. So I took the photo that you can see now, and I found it particularly interesting. You have this idea of Los Alamos where discoveries are made, right? And oh my goodness, it was absolutely fascinating to spend some time there and to know that, you know, just 75 years ago, the entire place was cloaked in secrecy. And even now, it's still this super top, you know, nuclear laboratory, Los Alamos National Laboratory, right? So I think it's a really fascinating place to go if you ever have the opportunity. So it was originally called Project Y, right? And I think it's really curious because while it still has this nuclear weapon lab in its site, in its city, it's also kind of made a big feature of its nuclear weapons lab. It's got museums and it's got all these tourist attractions. It even has a place called Atomic Knitting, which I found fascinating. And when we think about it through kind of social and cultural perspectives, and we think about it through kind of almost social science, I guess, and then it's made itself as a place. Its community has kind of taken ownership of its secret past and then branded itself in this way that it's the secret city. So it's got a Los Alamos Visitor Center, a Bradbury Science Museum, Los Alamos Historical Museum, Fuller Lodge Art Museum. And these places, they all retell the story of the atomic bomb and how it was made. They have the history, you know, they tell you about Oppenheimer, they tell you about the culture. You've got these wonderful models that are very tactile that you can touch. You can see what a nuclear weapon might actually be like. You can have a look at a sample of trinitite, the glass that sears into a crisp from sand when a nuclear weapon's detonated. And it tells the story of the atomic bomb, capitalizing on this culture of secrecy that used to surround nuclear weapons to kind of rework this public-facing history of Los Alamos. So it's really interesting. And one of my favorite stories, I think, is that of the Trinity test. That's depicted as kind of the birth of the atomic bomb, you would say. It was the first nuclear weapon test ever. And it was undertaken in Alamogordo, which is just south of Los Alamos. And this big, you know, kind of empty desert, essentially. And it was undertaken only on the 16th of July, 1945. And that was the first test that confirmed the science of the bomb. I think it's really interesting because when you go through the archives of the time, people thought they were going to destroy the Earth testing this nuclear weapon. They thought that it would catch fire to the atmosphere and that we would go down in this kind of glittering blaze. Obviously, you know, I'm talking to you now, so that didn't happen. While it demonstrated that the technology was feasible, nowadays things like nuclear weapons, well, the old technology used for the atomic bomb is very old indeed, you would say. So it's quite interesting. But one of the most interesting things for me about going to Los Alamos, it wasn't going to the libraries and going to the archives. It wasn't meeting that wonderful historian, who is wonderful. Would recommend if you're a researcher, go with a chat. He's really nice. It was actually visiting this place called the Black Hole of Los Alamos. So the Black Hole of Los Alamos belonged to a peace activist called Ed Grafus. He used it. He used to go to this place, I'm showing you now, every year, every weekend rather, to dress up in bishop's garb and unworship the bomb. He was so anti-nuclear that he used this space to kind of perform activism, and he was a complete embarrassment to the local community. So you can see here, here's one of the old signs. I did the first ethnography of the Black Hole of Los Alamos, the Church of High Technology and the Doomsday Stones, which I'll tell you a little bit about in a minute, as this kind of place, this space of activism, right? And so I was very lucky. His daughter, Barbara Grafus, took the time to talk to me and let me spend time at his home. And she spent time with me having conversations about what it was like to have Ed Grafus as her father. And I've written a little bit about this in my book. But it was very interesting seeing all these things, you know, critical mass every Sunday with bomb and worship service. Can you imagine having that going on in the very heart of the place where nuclear weapons were made in the depths of the Cold War? It is fantastic, isn't it? It's just such an interesting story. That's why I had to share it with you. And it's also time to share you the story with you about the time I climbed up a ladder and almost got myself stuck in a container with the Doomsday Stones. True story. So I really wanted to see these stones for myself. So Ed Grafus, a peace activist, nuclear Los Alamos, commissioned these 50-foot monoliths, and he got them inscribed with warnings about the dangers of nuclear weapons. Of course, they've never been erected in Los Alamos, so they're kept in these containers, they're locked away. And as you can see, there's one here, and it's inscribed E = mc² Albert Einstein, in honor of Albert Einstein, who became a big peace activist. In fact, he created the Einstein-Zizard petition to try and outlaw nuclear weapons in the 1950s, which is why it's on this monolith. And there were others locked away. You can see here is the base. Now, this is a really interesting object, because that black granite base, apparently, I am told, originated from one of the nuclear labs in Los Alamos itself and was used for seismic experiments. How cool is that? And then Ed Grafus bought it, took it away, and got it inscribed in 16 different languages. As I mentioned before, you can see here, I think it's in Portuguese, maybe. Can anybody read that? I wonder. But the essence of it is warning about the dangers of nuclear weapons, about how they're as brilliant as the brightest sun when they detonate, but actually how could we use these technologies for positive things for the future? How could we actually not use them for warfare? And you can see there it says bomb atomique single il-6 il-9 Augusto 1945. So that's kind of obviously highlighting the Hiroshima and Nagasaki nuclear weapon tests, nuclear weapon detonations of the 6th and 9th of August.
It's in Italian, Becky.
Is it? Oh, thank you. I wondered. I'm terrible with languages. So sorry.
I'm not taking credit for that. Andrea has posted that in the chat.
Amazing. So somebody who can read Italian will be reading this and going like, aha, that's really interesting.
Sorry, so while I've interrupted you, can I ask one other question in the chat? Background radiation in Brazil, where the nuts come from. Brazil nuts contain more K, so that's potassium, than bananas, and are also rich in Ra.
So it's not necessarily down to the background radiation, it's down to how much the plant absorbs it. I suspect that Brazil nuts, like tobacco, like sunflowers, are very good for kind of phytoremediation. They take up the radioactive aspects that are in the soil, and they absorb it. And there's an interesting story to go with that, actually. So, sunflowers, so their scientific name is Helianthus anus, and they're one of the best phytoremediators that we have, so one of the best plants for absorbing radiation from the soil. And one of the reasons why we learnt about this was actually in Chernobyl, from the environment in Chernobyl and from the sunflowers that grew there in contaminated places and contaminated sites. So I suspect that Brazil nuts, or Brazil plants, along with tobacco plants, along with sunflower plants, probably uptake radiation better. But it's also interesting from a perspective of whether you're a smoker, because I don't know if I've got any smokers in this audience, but tobacco is amazingly good at taking up radionuclides, and so every cigarette has a tiny little bit of radioactivity in it. And that's one of the reasons why it's not good for your lungs. Not to preach or anything, each to their own. Does that answer your question? So it's all about the environment that the plant is growing in, a little bit, but then mostly it's about kind of the nature of the plant and whether the plant naturally uptakes the radioactivity. Good. So let's move on to Chernobyl. And I think this is one of the most thought-provoking places that I can think of. I've got it described as a dilapidated post-nuclear city because it is essentially completely abandoned. But at the time that it came about, it was a very new, shiny, high-tech place for younger people to go and work and to kind of develop careers in the nuclear industry. It was considered to be kind of the pinnacle of technology at the time. I think it's really interesting how permanent evacuation has affected Chernobyl. So what happened is you had the nuclear accident, and then people permanently left the exclusion zone. So they were told never to return again. And I think that's really, really thought-provoking, because it's had these amazing ecological and environmental effects. And it's actually quite interesting. If you want to read a little bit more, I've got a friend called Johnny Turnbull, who's currently researching the dogs of Chernobyl. So he looks specifically at canids and kind of their lives and what they do, and what it's like for them living in this kind of new wilderness. But there's all sorts of other things that go on in Chernobyl that are really interesting, I think. So the things that I find really fascinating are the tourism, so how people go and visit Chernobyl now, right? And they go into the exclusion zone on these authorised and sometimes unauthorised tours. And it gives them this opportunity to kind of see this landscape that's been abandoned for so many years, since 1986. Or so it is said has been abandoned, but we'll talk a little bit more about that later. So the residents of Chernobyl, they were permanently evacuated. They became known as Chernobyllites. That's how they were described. After the meltdown of Reactor 4 on the 26th of April 1986. And it's become this place of like dark tourism, essentially. As a human geographer, I find Chernobyl fascinating because of the people it attracts and how people kind of interact with it and how they experience it. Has been described as a theatre of catastrophe. But there are issues with this kind of reinvention of Chernobyl as a place of dark tourism. So when we think about exposure and risk, tour guides take particular routes, but is their monitoring equipment appropriately calibrated? Is it respectful to the community? You have all these questions that need to be asked. Also, another interesting little thing I wanted to tell you about Chernobyl as well is, so when we think about it, we think about Reactor 4, we think about the accident, we think about this huge impact. But did you know that the other 3 reactors continued to run until the 1990s, with the last one was finally closed in, I think it was 1999. And so people were still kind of visiting and working on the other reactors, which I think is really quite interesting. So reactor 1, 2, and 3. And also, when we think about the area as being kind of this bleak exclusion zone, arguably that's inaccurate. So the were communities who lived there were what's known as the Babushkas of Chernobyl. So these women, these essentially older ladies who just wanted to return home, for whom motherland was motherland. So they went back and they lived there. And there's still a small community of them to this day, these older ladies who go out and they forage for food. Their relatives go in and visit them and bring them things, if they're lucky. But they grow their own vegetables, they pick berries and mushrooms. They do all the things you're not supposed to do in a radioactive exclusion zone. But they survive, they keep going somehow. I think their persistence is amazing. I think it's really interesting to kind of think through what their lives must have been like. And they say that they still have this strong sense of community, and it's very meaningful for them to live there and to be there and to be able to stay and be, and not to have had to have left home. So I also wanted to talk a little bit about what I call the nuclear climate change nexus. So this idea of drowning repositories, climate change concerns, but most importantly, how we can kind of think about communities who live in these places and give them a respect, the dignity and the autonomy that they deserve. Because I think this is a really big issue, is the fact that we've had like maybe nuclear weapon tests in the Pacific, and then we've had nuclear waste left in the Pacific, and there are communities who have lived there already for thousands of years. So how do we make sure that they're supported and that they get the respect they deserve? So I'm going to tell you a little bit more of a story, though, around nuclear weapons and the nuclear weapon tests themselves, because it wasn't just the local communities who were affected. There were also the nuclear weapon test, the nuclear test veterans, who young boy soldiers, on average about 18, 19 when they travelled, who had to undertake the menial tasks while the nuclear weapons were being tested. And they had quite a difficult time, so I'll talk a little bit more about them later too. So here's a photograph from Marilinga. I think it was actually given to me by one of my participants called David, and I think he gave it me. And Marilinga was a nuclear weapons test site in Australia in the 1950s. It was like British and Australian, but the British tested their nuclear weapons there. And unfortunately, they imported an awful lot of young men to do this work, while at the same time excluding Aboriginal communities from their homes. But it wasn't just the only place where nuclear weapons were tested, though. You can see on this map here that there's all sorts of other places, but there's this focus on Christmas Island, or Christmas. And so I'm going to tell you a little bit of a story about one of the communities that I've worked with most closely, just to kind of round up and to give a little bit of a taste of what I do on my day-to-day, I say day-to-day life, until this year, my day-to-day life. So I always remember I had this conversation with one of my nuclear test veterans about his experience. He said, I wonder what it was like, what it's like there now. You've got to bear in mind, when he was on Christmas Island, he saw this massive hydrogen bomb go off, literally his fists in his eyes, and he could see his fingers, right? And the flash was that bright. And then he'd spent the rest of his life wondering. So he wanted to go back. And so before I knew it, I was in Christmas with my nuclear test veteran cohort. And so on the 28th of April 2018, we went out there so I could document them commemorating the 60th anniversary of Grapple Y. So on average, the men who I travelled with were in their early 80s, right? They ranged from 79 to 82. And they were determined. They'd gone halfway across the world in their dotage, if you'll excuse me if any of you are listening now, to go and see what it was like now, to try and reconnect with the communities and learn what life was like. And it was an absolutely profound experience to see them. I travelled with them. We met in Sydney, and we got the flight together, and to watch them touch their feet down from that flight back onto the tarmac of this place they left 60 years ago. Can you imagine? It was astonishing. And so they commemorated their experiences. They built a memorial. They had a memorial for the people of Christmas and the UK to reflect upon kind of their experiences and what it was like for everybody involved. And they had this tremendous, I show you this photograph because I think it gives a really interesting perspective, but also because I particularly enjoyed their ferocious pacifist priest that they had. She was brilliant. But they were there, they came back, and they had changed, they had become old, and the island too had changed. The barracks where they stayed, well, the officers' mess, where they used to kind of see the officers, had become the local hotel. So we stayed in the officers' barracks, and there were lots of laughs about this idea of kind of returning to the place where they saw this hydrogen bombing detonated. This massive nuclear weapon, but also kind of finally getting into the officers' barracks and getting the good beds. And it was really interesting, actually, to see the two communities kind of connect. It wasn't always smooth, but they got there, and they shared stories and experiences. And I think photographs were particularly amazing for kind of provoking that insight and that understanding. And there were parallels to the experiences of the island communities, to the Christmas people, and to the veterans themselves. And neither community were told about the harm that they could encounter due to nuclear weapons testing. And so there's this challenge of not knowing, this challenge of uncertainty about the long-term effects to their community and their health. Both communities were concerned about the hereditary effects of ionizing radiation, and it's really difficult. I am a social scientist and a natural scientist, but I'm not a geneticist. So I did a unit in health physics in my bachelor's. I've studied to make models for radiation protection, and I've written about communities, but I couldn't possibly tell you. It's not within my area of expertise to know if there's any genetic damage to either community. But there is this concern, and often, even if the effect even if we don't know if the effect is there, that concern has a, psychosocial effect, doesn't it? It has an impact upon kind of the life that people lead. So it was really good to see them get together and be able to share these stories. And thinking on as well, so I mentioned this idea of drowning islands. Both Charismas, the Marshall Islands, so the Charismas is a British test site, the Marshall Islands is the American test site, and French Polynesia is the French test sites that we used during the Cold War. So this is in our lifetimes for many of us who are listening tonight, right? All of these places are affected by the climate crisis right now. So all of the islands and these environments where people live have been affected, and this is kind of a long-term consequential effect. It's really difficult for the communities who live there because it's their home. They don't want to leave. So we need to think of ways to support them and to help them move forward and help them maybe preserve that island through geoengineering or help them migrate, but listen to their voice, listen to what they want to do. So I'm going to tell you about somewhere in the Marshall Islands now. It's another place that's quite dear to my heart because I've got a few Marshallese friends and I've spoken to them lots about, what it was like growing up being Marshallese. And Eniwetok Atoll is part of the Marshall Islands, and it has something called Granite Dome on Granite Island. And Granite Dome was built from 1977 to 1980, and it stores the radioactive waste from the American nuclear weapon tests during the Cold War. So this happened almost in my lifetime. I'm not quite old enough, but almost in my lifetime, right? So this is on Marshallese lands, and now there's a big challenge that's emerging because as climate change happens, as climate change is affecting these island spaces, it is also affecting Granite Dome. It's affecting the concrete. It's sneaking up very gradually. So it's vulnerable to these climate change effects, and it might pose a future risk to the people of this region. If, for instance, Granite Dome springs a leak because sea level's gone up too high. So there's a huge issue. It needs to be resolved. Someone needs to plan a major operation to relocate the materials within Granite Dome to somewhere that's secure and to rehabilitate and remediate that environment. And it's no minor job. It will cost billions of pounds, but it must be done. So I'm going to talk a little bit about Hiroshima as well, just to kind of round off the talk, because you can't really, talk about the nuclear and talk about nuclear culture without Hiroshima. It's such a prominent part of nuclear culture, isn't it? We've all heard of it, and it was the 75th anniversary of the bombing this year. So you can see here, there's some of the men who were on the Enola Gay, who were part of that brigade that dropped the bomb. It was the Enola Gay that dropped the bomb on Hiroshima. And when it was bombed, 90% of the city's 76,000 wooden buildings were partially or totally incinerated. Concrete would turn pink from the radiation and was reduced to rubble. And about 120,000 people died. So some died immediately from radiation exposure, from this deterministic radiation exposure. It zaps out your immunity if it doesn't vaporize you if you're right at the epicenter. It destroys your immune system, and so you die quite quickly with acute radiation syndrome with very high levels of exposure. So there was this huge problem. People had radiation burns, they were injured, it was terrible. But the city has somehow recovered. So the Shigogu Shimbun newspaper launched a competition in 1946 seeking readers' visions of the city. And this competition was won by Sankichi Toge, who suggested an international peace memorial garden with a museum and a library. And it's been remade as this place of peace. Here you can see part of the peace garden. And at the end of that arch, you can see the memorial dome. So this is part of one of the buildings that survived. And it's been left as is to remind people of the harms and the wreckage, you can see it again there, of nuclear warfare. So these are some of the women who survived, and they became known as the Hiroshima Maidens, and I've written about them quite extensively because I'm very interested in how women experience things like nuclear warfare. And these women are of particular interest to me because they were provided with reconstructive surgery in the USA. So they were, the USA bombed them, but the USA also, in a way, saved face. But obviously there's a lot of complexities and issues around the selection of these 25 women. You know, some people have said it's tokenistic. So it's very interesting thinking about their lives. And there's many different ways. When I talked about culture, there's many different ways that Hiroshima has been memorialized. Hiroshima and Nagasaki survivors, several of them have written poems. I always think this one's quite striking. You know, carbonized bodies face down in the nuclear wasteland. All the budders died and never heard what killed them. Thinking of myself as a phoenix, I cling on until now, but how painful they have been. Those 24 years past, so reflecting upon kind of the long-term effects of Hiroshima to himself. And so I've written...
Becky, can I ask you a question there?
Yeah.
Okay, so you say 90% wiped out in Hiroshima, but just to kind of put that in a sort of a physical sense, if you dropped a bomb on Hume, would it wipe out Altrincham, etc.? Just sort of geographically.
Oh no, that's a really, really good question. So if you dropped the same bomb on Hiroshima, 75,000 buildings, you would wipe out, I'm just thinking from I should have put a map in. I'm a geographer, what am I thinking? So I guess it depends on the population density. So I'd say I'd easily wipe out the city centre of Manchester. So that area, that whole city centre area would go. So, and I'd say I'd count the areas being kind of from the museums to up to like the football museum and down to the universities. So, so a wide area would go. But it depends upon the scale. So Hiroshima would destroy our city centre. With the contemporary bombs that we have now, it would go beyond the city itself and it would potentially destroy the region. So Hiroshima is actually a really small nuclear weapon compared to kind of the arsenals that we have now. And that's one of the reasons I talk about kind of nuclear weapons and nuclear culture, because I think it's interesting when we think about the devastation that Hiroshima caused and that we have weapons that are magnitudes you know, bigger and stronger nowadays. Does that help?
Yeah,
Next time
thank you.
Thank
No,
you.
it's fine. I know which way to run.
Yeah,
thank you.
No problem. There's a really fun little app actually. Don't take it too seriously, but it's called Nuke Map online, and it's by a historian called Alex Wellerstein. And what you can do is you can choose a detonation size and then detonate your city. It gives you kind of an estimation of kind of the area that would be affected if you don't take into account things like wind speed and that sort of thing. So well worth checking out. Does that help as well as an extra resource? You can all get on your laptops now and have a little look. So I think it's really interesting actually how these places are constantly evolving and changing and adapting and developing. So as you can see, I've just put life after the bomb. I'm exploring the psychogeography of Hiroshima. But I do think that things change and things evolve. And I think there's still a lot of change and evolution to happen. So to kind of conclude, I guess, nuclear places face a diverse range of challenges. There's challenges that can be overcome. There are challenges that can be subverted. There are challenges that are celebrated. And some places are reinvented in ways that you would never expect. Like Hiroshima as a place of peace, or Chernobyl as a place of tourism. You can see here the photograph from the original nuclear weapon test. I keep saying test, that's not what I mean. The detonation of Hiroshima, the destruction of Hiroshima, to Hiroshima now, in the present day, you can see the difference. That's just a photo I took from the same vantage point. If you found this interesting, if you'd like to learn more, then I've written a book called Disarming Doomsday, and I mean this is just like a tiny snippet really of the kind of areas and the places and spaces that I've considered. I've done everything from speaking with the women of Greenham Common to speaking to the French scientists who worked on the French nuclear weapon tests. So it's been such a pleasure to talk to you. Thank you everybody who came to hear me talk tonight. It has been wonderful. And if you want to get in touch, I'm on Twitter as Mysterious Dr Bex, or as you know, I'm less mysterious than I make out. And it's #nuclear geographies. So yeah, any questions? I love a question. There's no such thing as a question. It's too big, too small, or anything. So it's been such a pleasure. Thank you.
Thank you, Becky. This is the point, I think, where if we were physically connected, we would all give Becky a round of applause for that. So if you want to unmute your microphone and say thanks,
thank you.
much appreciated.
Thank you.
Brilliant.
Thank
Let
you.
me say,
Oh, I
this
can
is
just
a
see
snippet
some
of what you have done. There must be
questions.
plenty of books in you.
What, me? Oh god, yeah. No, I've already so I'm really shocked. As I said, my books appear to be award winning, and so I'm writing some more. Oh, is somebody crackling?
I just want to say you've done a fantastic job, a fantastic speech, and
Oh,
you
thank
deserve
you.
every minute of it.
Oh, that is so kind of you. You are very generous. I'm just currently scrolling through and looking through any questions that I have.
You know who I am, I guess.
Amazing questions. Oh, thank you, Andrea. Oh my goodness. And yeah, wildlife has wildlife has become really abundant. In fact, it's now a UNESCO protected site for Chernobyl for wildlife, because things have grown and thrived and flourished. But that's not the complete story. So there's scientists like Dr. Tim Musso and John Turnbull, who I mentioned earlier, who are out there learning about what life is actually like to be an animal in the zone. So while there's less humans, so more opportunity for things to grow, sometimes things don't grow in exactly the same way, or there's differences. So it's well worth checking out those people's work. Oh, and also we've got a local radio ecologist, actually. He's really good, called Professor Mike Wood over at Salford. So
Yes, I've met him and I've seen his Chernobyl event. I volunteered for it some years ago.
Yeah.
And it was fantastic. And so I do know that it's actually a myth that people believe that there's nothing there anymore, when it's, there's lots of plant life and animals and everything. So yeah, so that's why I'm comment question, because I wanted it to come out that yes, there is lots of wildlife still going on there. And did this event, I've been actually fascinated with Chernobyl.
Oh,
yes, I did meet Mike Wood. He was great, him and his team. Yeah.
Yeah, he is, isn't he? And yeah, no, wildlife is so abundant because it's what happens when humans go, the creatures take over.
Yeah, a bit like they seem to be doing during our current pandemic.
Yeah, exactly.
Just not wanting to barge in, but just before people start dropping off, thank you very much for everybody who attended tonight. We're looking at our next sidebar on October the 19th. It's normally the third Monday of the month, but next month's speaker has unfortunately had to drop out. Sarah's posted in the chat about it, but if there's anybody who would be interested in talking to us for half an hour, 45 minutes or so, please get in touch. If you want to drop off now, you're welcome to. The format tends to be, from this point in, a bit of a Q&A session with Becky for as long as she's prepared to stick around, or you have questions for her. So thank you everybody for attending. Carry on the chat. Thank you.
No, that's brilliant. I'm so glad. I just noticed a question on the Kataribe tales.